Hello everyone, in this video we are going to start a new subject, Strength of Materials 1. We have already studied engineering mechanics in your second semester. Now, stepping into the department subjects, Strength of Materials is a basic and a very old concept in civil engineering. And later on it is known as modern mechanics and material science. Here, we're going to come across the terms like stress, strain, tensile, compression, beam, column, shear force, bending moment, deflection, elasticity, factor of safety, Poisson's ratio, and so on. Stress analysis is a primary task for civil engineers as well as mechanical and aerospace engineers also, which are involved in the design of structures of all sizes such as bridges, aircraft, mechanical parts, even in plastic cutlery and staples. Stress analysis is also used in the maintenance of such structures and to investigate the causes of structural failures. Typically, the starting point for stress analysis or a geometrical description of this particular structure, the properties of the material used for its parts, how the parts are joined, and the maximum or typical forces that are expected to be applied to the structure. The output data is typically a quantitative description of how the applied forces spread throughout the structure results in stresses, strains, and deformation of the entire structure and each component of that structure. In this unit, you are going to study about the basic concept of simple stresses and strains, which can be tensile stress and tensile strain, compressive stress and compressive strain, shear stress and shear strain, and the relation between the elastic constants. And we are going to draw a curve, a beautiful relationship about the stress strain curve. A very basic concept we have to know about is the ultimate stress and yield stress. And knowing about the varying sections of the bars of the material, composite bars covers those problems which we faced in further classes. The state of stress in two dimensions, the stresses which acts on the inclined plane, on the principal plane, which is known as principal stresses. And we're also going to calculate these principal stresses and shear stresses by Mohs circle method. In unit 2, we are going to study about the types of loads, types of supports that acts in beam, the basic concept of shear force and bending moment. Here you will know what is the force which acts and what is the difference between the force and moment, the relation between intensity of load, shear force and bending moment. And we are going to see a lot of diagrams based on combining both load and the types of beam. There are going to many of the diagrams. We are going to draw shear force and bending moment diagram for cantilever beam, for simply supported beam, for overhanging beam, based on their loads of concentrated load, uniformly distributed load, uniformly varying load. We are going to know the difference and we are going to draw a various diagrams. And a simple bending theory. stress distribution due to bending moment and shear force. In addition to this, we are going to study about the flitch beams and leaf springs in this unit. In many cases of structural and mission designs, members must resist the force applied laterally or transversely to the axis. Such members are called beam. Beam deflection means the state of deformation of a beam from its original shape under the work of a force or load or weight. One of the most important applications of beam deflection is to obtain equation with which we can determine the accurate value of beam deflection in many practical cases. Deflections are also used in the analysis of statistically indeterminate beam. Several methods are available here. The principle is the same but differs in technique and in their immediate objective. They are direct integration method, area moment method, conjugate beam method, McEldee's method, and also method of superimposition. Unit 4 is torsion. The force that gets developed upon twisting one end of an object while rotating another end in the opposite direction or keeping it in a fixed position is known as torsion force. Response to torsion force depends on the nature of the object. For example, the brittle object breaks down, the elastic object regains its original shape as soon as the force is removed. The flexible object gets deformed. Torsion force is responsible to twist or turn an object. It is also known as twist force. In the absence of torque and torsion, the objects would be able to exhibit linear motion only. Torsion force or torque is a moment of force that can be easily calculated by multiplying the force acting on an object with the distance between the reference point and the object. Unit 5, Analysis of stress. A structure that is composed of number of bars pin connected at their ends to form a stable framework is called truss. It is generally assumed that loads and reactions that are applied to the truss only at the joints. A truss would typically be composed of triangular elements with the bars on the upper chord under compression and those along the lower chord under tension. Trusses are extensively used for bridges, long span roofs, electric tower, and space structures. Trusses are statically determinate when the entire bar forces can be determined from the equations of statistics alone. Otherwise, the truss is statically indeterminate. For truss analysis, it is assumed that bars are pin joint, joints are frictionless hinges, loads are applied to the joints only. Stress in each member is constant along its length. The main objective of truss analysis is to determine the reaction and member forces. The methods used for carrying out the analysis with the equation of equilibrium and by considering only parts of the structure through analysis its free body diagram to solve the unknowns. Strength of materials on the whole is used to calculate stresses and strains in a material for a given application. It helps us to determine what type of material should be used, how much of it, and the shape of the structure. It's used for everything, for example cars, bridges, buildings, aeroplanes, even in a laptop, mobile. Virtually anything that has withstand some type of force. Strength of materials is relevant in every object. A plastic wrapper, even in a sewing thread, hairbrush, nail clipper, fabrics, a bag of chips, in short, in everything.